Good morning, dear students. Welcome back once again with the continued portion from the displacement reaction. See, in the last class, I was discussing with you the different types of reaction. Now, over there, I had discussed with you the combination or the synthesis reaction and the decomposition reaction. Okay, I have explained both the reactions over there. Now today we will learn about displacement reaction. See, this displacement reaction is sometimes known by the name of single displacement reaction. Okay, this is also known by the name of single displacement reaction. Now, why is the name so given? Either you can call it as displacement or single displacement. See, generally what happens, displacement means somebody will displace the other. Take for example, you people have read history, I suppose, isn't it? Okay, now over there, it is already known to you that a strong ruler will always evade. Okay, a strong ruler will always get victory over a weak ruler. So if that is the case, that a strong ruler is going to win, over here also we have the same concept. But before I move into the details of the reaction, let me tell you something about the metal activity series. Though you have learned earlier about the metal activity series, but let me remind it to you once again. See, the metal activity series, it will tell you about the reactivity of different metals. Okay, it will tell you about the reactivity of metals, which metal is more active, which metal is less active, which metal is going to react with water, which metal will react with acid, which metal is going to react with steam and all. So all these details will be provided to you by the metal activity series. So I'm writing the series for you. Pota, Sodi, Cal, Mag, Alu, Zinc, Iron, Tin, Lead, Hydro. That is, this is hydrogen. After that you have copper. We have copper, mercury, silver, platinum, gold. Okay, so this is the entire series. So potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, platinum, gold. Now, how is it going to be arranged? Look very carefully. The moment you start moving down the group or down the series, the reactivity will go on decreasing. The moment you start moving down the series, the reactivity will go on decreasing. This hydrogen, after which these elements that you are getting, they are least reactive. That means they basically don't react very well. That means all these are weak elements. Okay, all these are weak metals. These are some strong metals like potassium, sodium, calcium. They are all strong metals. But the moment you start moving a little down, zinc, iron, tin, they become a little weak. Is it clear to you? So this is the activity series. Now we will use the activity series for the displacement reaction. Let us see how. The general form of a displacement reaction is like this. Suppose we have a reactant as A that is reacting with another reactant BC. We have a reactant A which is reacting with another reactant BC. Now, you have to consider over here that is A is strong in nature and B is a weak metal. Okay, B is a weak metal, A is a strong metal. Now, if that is the case, that A is strong, B is weak, so what will happen over here? A will displace B out from its position. A will push B out from its position, and the product that you will get is AC plus B. This is the product that you will get as a result. Okay, so look carefully at the equation. That is, A is a strong metal, B is a weak metal. So being weak, B will be displaced by A and the product will be formed like this. Okay, now let me give you one example for it. Look very carefully over here. The example is like this. That is, okay, look at the metal activity series. I'm giving you the example. Fe, this is in the solid form. Okay, iron, this is in the solid form. This is reacting with copper sulfate, CuSO4. This is in the aqueous medium. Okay, CuSO4. This is in the aqueous medium. On reaction, Fe in the solid state is reacting with CuSO4 in the aqueous state. What will the product will you get? You will get FeSO4. You will get FeSO4 because Fe will combine with SO4. You will get FeSO4 plus, you will get FeSO4 plus Cu solid. Okay, FeSO4 will be in the aqueous medium. Now look very carefully over here. Fe is in the solid state. We have taken solid iron. This is reacting with copper sulfate in the aqueous state, and we are getting the product as FeSO4 in the aqueous state along with copper in the solid state. Now, if you look at the activity series, see, iron is present over here, copper is present over here. So iron is present above hydrogen, copper is present below hydrogen. Iron is present above, copper is present below. That means copper is weak as compared to iron. Copper is weak as compared to iron. So what will happen over here? Here the thing that will happen is that iron will be able to displace copper from its solution. Is it clear to you? Okay, so this was about your displacement reaction. Now, let me give you one more example for the displacement reaction. Tell me what will be the product of this particular kind of reaction. You have to predict the product for the reaction. We have copper in the solid state, which is reacting with ZnSO4, zinc sulfate, in the aqueous state. So what will be the product for this particular kind of reaction? Anything. This reaction will not take place. No products will be formed. What is the reason behind it? No products will be formed. The reason is very, very clear. The reason is copper is weaker as compared to zinc. Copper is a weak metal as compared to zinc. So, copper can never displace zinc from its solution. That is why the reaction will not take place and you won't get any products over here. So, is it clear to you, everybody? Okay, now let us move on to another reaction which we call it to be as double displacement reaction. See, if you hear the name double displacement, see, from the name itself you will get some idea. That means two types of displacement are taking place over here. Okay, you will get an idea. That is why this reaction is called as double displacement. The reason is two types of displacement are taking place over here. So double displacement reaction. Now so what happens over here is that in case of double displacement, take for example, I am having a reactant AB and I am having another reactant CD. So I'm having both compounds over here. So this is the reactant side that we have. Okay, this is a general reaction, I'm showing it to you. So AB and CD, these are the two equations. Now, on reaction, what is the product that you will get? You will get AD plus BC. This is the product that you are going to get. So how is this product available to you? Look very carefully. This A will react with D and B will react with C. That is why we are calling this reaction as double displacement. The previous reaction, only single displacement was there. Only one element was being displaced. But here we are having two displacements. Because of the two displacements, we call it to be as a double displacement reaction. Okay, let me give you one example. See, lead nitrate PbNO3 whole 2 on reaction with potassium iodide Ki. Okay, lead nitrate. This is lead nitrate. This compound on reaction with potassium iodide, what is the reaction do you expect? The reaction will be lead iodide. Okay, it will form lead iodide. Now, once it forms lead iodide, along with that, what will be formed? Potassium nitrate. Potassium nitrate. This is a salt which will be formed in the reaction medium over there. Okay, so this is a general reaction which we call it to be as a double displacement reaction. Now look carefully. Lead is going with iodine, so lead iodide. Potassium is going with nitrate, so you are getting potassium nitrate. Now let me show you the reaction, how it takes place. See, I have got two containers over here. In this, I have taken the salt of lead nitrate in the aqueous solution. It's just an aqueous solution of lead nitrate. Is it clear to you? And in this, I have aqueous solution of potassium iodide Ki. Okay, this Ki, I have taken it into it, and this lead nitrate, I have taken it into this particular container. See, look very carefully. It's a bit hazy type of solution. The reason is we have made the solution in just normal tap water. If we had prepared it in distilled water, it would also have been a clear solution like this. Okay, this is a distilled water solution. Now look very carefully. On reaction, what are you going to get? You will get lead iodide and potassium nitrate as a salt. It will be formed in the medium. So that potassium nitrate which is formed over here, we will not be able to see anything of it. But we will be able to see this lead iodide form. How? It's a brilliant canary yellow color. Okay, it's a brilliant canary yellow color precipitate that you will get. Yes, it's really a brilliant one. A canary yellow precipitate formed of lead iodide. That means your double displacement reaction has taken place. This precipitate is a proof that your double displacement reaction has taken place. Now see, so this lead iodide, it is formed as a precipitate, and what is the color? The color is canary yellow. Yes? So, isn't it? The color is a brilliant canary yellow precipitate. Okay, fine. So this was about your double displacement reaction. In your book, you will find some more examples over there. So just go through those examples. Now, let us move on to another interesting part over here in the types of reaction. That is, you have already learned about that type of reaction. The reaction is neutralization reaction. Now see children, what is a neutralization reaction? Basically what happens, neutral means what? Do you have any idea about it? Neutral means to cancel the effect. Okay, neutralize, the word neutralization. Okay, this is the word that we are using, neutralization reaction. Now, over here, this word that is neutralize, this particular word, it actually means to cancel the effect of something. Now, to cancel the effect of something, what does this mean? This actually means that in this particular kind of reaction, we use a specific reactants over here. Okay, we use some specific reactant. I'm showing you the generalized form of a neutralization reaction, that is acid plus base will give you on reaction salt and water. This is a basic generalized form of a neutralization reaction. Now, how are we going to explain it? See, over here I'm using acid and I'm using a base. That means the effect of base will be neutralized by acid and effect of acid will be neutralized by base. Is it clear to you? Effect of acid will be neutralized by base and effect of base will be neutralized by acid. That means I told you to cancel the effect of something. That means acid will cancel the effect of base, base will cancel the effect of acid. So let me give you one example over here. See, we have very common example, that is HCl. HCl, all of you know what this acid is? Hydrochloric acid, which on reaction with a base, that is sodium hydroxide, NaOH. Okay, on reaction with sodium hydroxide, what will it form as a result? It will form salt and water. So the salt which will be formed over here is the common salt that you use in your home. That is sodium chloride. This is the normal common table salt that you are using in your home. Okay, that means if you look carefully over here, HCl, that is hydrochloric acid, on reaction with sodium hydroxide, what happens over here? It will give you NaCl and along with it water will be formed. If you look very carefully at this neutralization reaction is also a double displacement reaction. This neutralization reaction is also a double displacement reaction. If you look carefully, you will see that this is also a double displacement reaction. See, we have double displacements over here. Sodium is going with chlorine to form NaCl. Hydrogen over here and hydroxyl over here, that is forming water over there, isn't it? This is forming water over here. So, okay, once it is forming water over there, that means this neutralization reaction is a kind of double displacement reaction. Clear, everybody? Okay, now let us move on to the next area. We call it to be as a precipitation reaction. Now children, what do you understand by the term precipitate? Okay, precipitation reaction. Now what do you understand by the term precipitate? Precipitate actually means to settle down. Okay, precipitate means to settle down. That is, something is going to settle down at the bottom. That means it must be a thick and heavier one. That is why it will settle down at the bottom. So we call it to be as a precipitate. Now, I have shown you one example over here. If you look carefully over here, you see a yellow precipitate has settled down at the bottom of the beaker. Now this precipitate which has settled down is an example of precipitation reaction. I am writing the reaction once again for you. That is the precipitation reaction. I am writing it again for you. Lead nitrate on reaction. Okay, lead nitrate PbNO3 whole twice on reaction with potassium iodide, on reaction with potassium iodide will give you lead iodide as a canary yellow PPT. It will give you canary yellow PPT of lead iodide, and along with it a salt will be produced, that is potassium nitrate. Okay, this is a salt will be formed. This is potassium nitrate. So this is an example of your precipitation reaction. We have some more examples for the precipitation reaction. I'll show you some more examples in the next classes, okay? When I will be teaching you about the analytical chemistry and all, there I will show you more examples from the precipitation reaction, okay? So this is an example for the precipitation reaction. All of you can see it over here. A canary yellow precipitate has been formed of lead iodide. Okay, for lead iodide, I am having a canary yellow precipitate over here. So that is why this reaction is called as precipitation reaction. Alright, now obviously precipitation reaction is also a kind of double displacement reaction. Okay, see over here also I am having two displacements. Lead is going with iodine, potassium is going with nitrate. So I am having double displacements over here. Okay, now see, so the next part is a very, very interesting one and very important one that we will learn. Is it's a completely different type of reaction that we are going to study it over here. Though we call it to be as redox reaction, but actually the word redox has two parts involved in it. Now what are the two parts which are involved in it? See, from the name itself you will be able to write the definition for it. See, this portion stands for reduction. Okay, this portion stands for reduction, and this particular area stands for oxidation. So, from the name itself, it is clear that is a type of reaction where oxidation and reduction will take place simultaneously. Simultaneously means together. Both the reactions will take place in a single reaction. Then that reaction will be classified as redox reaction. But before moving into the details of redox reaction, let me tell you what is reduction and what is oxidation. Okay, so look very carefully over here about oxidation and reduction. I shall make you understand in the two different columns. See, this side we are writing it as reduction, and over here I am writing it as oxidation. Now, look very carefully. The simple definitions that you have learned till now, okay, the normal definitions in your junior classes that you have learned till now about reduction and oxidation. What that concept is? The concept is like this. Reduction, that is, you have learned a concept, addition of hydrogen atom. Okay, if I want to reduce something, I have to add hydrogen atom to the system. Okay, on adding hydrogen to the system, the substance will be reduced. Or the reverse of this, okay, removal of oxygen atom. This is the common definition for reduction that you have learned. Either addition of hydrogen atom or removal of oxygen atom is the definition that you have learned it for reduction. Okay, is it clear to you? Fine. Now, let us move on to the oxidation section. What does it say? It says just the opposite. Okay, just the opposite of this it is going to say it over there. That is addition of oxygen. Okay, addition of oxygen atom or removal of hydrogen atom. That means, see, reduction and oxidation are just opposite of each other. For oxidation, I am telling you addition of oxygen or removal of hydrogen. For reduction, I am telling it to you addition of hydrogen or removal of oxygen. Any of the process will tell you about either reduction or oxidation. Any of the process, either this or this. Any of the things can be there. For oxidation also either this or this. So any of it can be possible. So if that is there, then the process will be classified according to the changes taking place. Okay, let me give you one example. See, carbon. This is your normal carbon that we have seen. So this on reaction with oxygen, okay, just normal oxygen gas, this is reacting. What will it form? It will form carbon dioxide. It will form carbon dioxide. So this reaction is a kind of oxidation reaction. Is it clear to you? So children, in the next class, we will continue from the oxidation and reduction area, and we will see more of the reactions. Till then, go through the reactions that I have taught you and get this jotted down in your copies. So, goodbye all of you.